You're listening to the Banana Data Podcast, a podcast hosted by Dataiku. I'm Triveni.
And I'm Will.
And we'll be taking you behind the curtain of the AI hype, exploring what it is
and what it isn't
capable of. Today, we're starting episode 1 of a 2-part series on open source. In this episode, we'll be speaking with Andreas Mueller, a core contributor to Sci-Kit Learn, about the value of open source for the community and how they ensure integrity in their software. Stay tuned next week for part 2 of the community behind open source. So today's episode, is the first of a 2-part series on open source development. I guess my question is, what really is open source, right? I think I know what it means, but it doesn't seem like there's a real clear definition out there.
Yeah, so I'm excited for the conversation that we're going to have today, all about open source software in particular. And so when I think about open source software, key distinction that I make in my mind is that it's software that anyone can view the underlying source code for and even inspect it and modify it. So anybody can go in, can tweak code to their heart's desire. The one distinction I would make is that open source does not necessarily imply free. So just because someone can manipulate the underlying source code, it doesn't necessarily mean that that software ultimately will be free to use. And also there's some tools that are free but not open source. So it gets a little bit confusing.
So maybe an example then of this is that Python and R as coding languages are open source, but a product like Dataiku is free but not open source.
That's exactly right. Yeah. So languages like Python and R, which we talk a lot about, are indeed open source. And as we'll discuss very much today, there are libraries or packages that are included or can be written for these languages like Sci-Kit Learn. So Sci-Kit Learn is a great example of an open source software tool.
Okay. Yeah, I think I'm excited to talk to Andy today just because I want to understand what it's like to actually develop open source tools when there isn't some sort of company or business line driving it, right? Like these are people contributing out of the goodwill of their heart.
Yeah, it's super interesting to think about how open source projects are motivated. And then ultimately decisions do have to be made too, right? So if I log in to Sci-Kit Learn and I submit what's called a pull request, which is basically me making a change and hoping that that change is accepted, somehow someone determines what is kind of production level Sci-Kit Learn. And so just like any other organization where groups of individuals make a common decision, open source software consortiums have to do the same thing too, right? They have governance structures internally. They have people that somehow determine what gets included, what gets excluded. But again, open source is something that at face value, anyone can see the code and modify the code.
Well, welcome to the podcast, Andy. It is so exciting to be here.
Thanks for having me.
So tell us a little bit about yourself. How did you come to be involved with Sci-Kit Learn, your path to where you are now?
The project was started by a team in Paris, most of them working at INRIA, and a lot of them are still active. So they were a team of about 3-4 people. Now they're about 7. So back then I started just contributing in my free time during my PhD. So that was about 7 years ago when I started contributing. They asked me at some point to become release manager. And so I started doing the work for curating the releases, making sure things get done. I was like one of the most active people on the project for a couple of years. In the last year or so, actually, we've gotten a lot more full-time contributors. And so structure changed again. And so I'm now not doing that much coding anymore, but I'm leading a team of 2 that are working on Sci-Kit Learn full-time. And there's several people now in Paris who can actually work full-time on Sci-Kit Learn as well.
So it's its own organization almost in its own right now.
Well, there's several different organizations. So there's an open source project, which is, we have a governance document. And so we're an informal organization in a sense, and we're a GitHub organization, whatever that means. But there's several entities where people group and work. And so one of them is mainly INRIA and the Sci-Kit Learn Foundation. Then I'm at Columbia with 2 other people working for me at Columbia. Then there's more independent contributors. And then even we have someone else, Adrian, working on Sci-Kit Learn full-time as part of Anaconda.
So you mentioned GitHub. So maybe taking it back, can you just talk a little bit about contributing? Like, what does that actually mean? Maybe to start, how does one even literally contribute to an open source project like Sci-Kit Learn?
GitHub is really the main platform for the project, and it's the main way we communicate. And that's intentional because GitHub is a very open platform. all the repositories are public and everybody can see what's going on. And so we try to keep as much of the communication on that platform as possible so that our decisions are transparent and our development process is transparent. If you want to contribute, the easiest way is usually either opening issues of things that don't work for you or where you feel like the documentation is unclear or wrong, or attacking an issue that someone else pointed out. Sometimes we have people coming in saying, oh, there's this algorithm I really like, but it's not included. Can I help include this algorithm? But that's really actually a lot of work. And even for people that are deeply involved in a project, including a new algorithm usually takes several months. So I started fixing typos in the documentation.
Valuable stuff.
And doing some formatting and so on. So I always recommend for anyone that's new, just start simple, get into the process, like the GitHub workflow, and like engaging with the contributors, then go from there.
Well, so on that note, then, can you tell us about the governance structure that you use at sklearn, to decide what algorithms are going to make it in, what issues are going to get prioritized, and when a release is going to get scheduled, those kinds of things?
So interestingly, for the longest time, Sci-Kit Learn didn't have a governance structure. So we're now coming up on the 10-year anniversary of the first release, I think. And we've had a governance document for about a year now. So it was one of the things I really pushed for. Maybe let me describe a little bit how it was before and how it is now. And so before, basically, we were governed by consensus of everybody that wanted to be involved. That was mostly the people with commit rights. So there's one concept that we had the whole time, which is what we called core developer, which is basically the people with commit rights. And they were nominated by the community, and then the community agreed, so I don't think there ever was a no vote on don't make this person core contributor. So someone started contributing, and then at some point there was like an acknowledgement, we should give this person commit right because they showed skill and we want to encourage them to commit more and take on more responsibility. And this rule has been the same the whole time. But now we formalized more, how do we actually make decisions? Before it was just consensus-based. But one issue that I saw with this in particular was that there's no way to resolve conflict. There's a long write-up of how Node.js ran into this problem where they didn't have a conflict resolution mechanism. And so basically what our current governance model is have consensus among the core developers. And if there can't be consensus, then we revert to voting. And if there's a tie in the vote, then there's a technical committee, which is 7 people that are also voted in and nominated until they resign, basically. But they're mostly there for tie breaking. So we have sort of an inner group, but they're in a new governance structure, but their role is mostly tie breaking, and they commit to steering the project, but they don't really have more power than the core developers.
What do you mean commit to steering the project? So is that like they are deciding the next phase or the roadmap for sklearn?
They say they will help build the roadmap. Like there is no really formal decision power. So we are doing the roadmap in like pull requests, and we're discussing, and all of the committers and contributors can contribute to this. Even people that are not contributors can just go on the issue tracker and say, hey, why don't you add this to the roadmap? Or I don't think this is useful. And we will take their comments into consideration. It's more like similar to my role as the release manager before. It's more like you need to have dedicated people to do certain things, otherwise they don't get done. And so in particular, if it's volunteer driven like it is, or mostly volunteer driven, then you need to make sure the responsibility is somewhere. And basically a technical committee says, we're responsible for driving this project. And it's not like their voices count more, but they say, we're actually going to do it.
So in terms of that idea of volunteers and how you encourage contributions, I'd love to dig a bit more into that. So how do you support people who are contributing to Sci-Kit Learn, right? And I guess explicitly, we can maybe talk a bit about the finances of it all, right? So if I'm spending a lot of time, which does take a lot of time to build such a robust framework, how does that happen? Is it just great people spending their nights and weekends doing it? Are some people paid by the foundation? Are some companies supporting this?
So for most time of Sci-Kit Learn, it was mostly volunteer contribution, mostly by PhD students and postdocs. So it was very academic. Now, as I briefly mentioned earlier, in the last maybe 2 years or so, this transitioned more to a full-time model. And so right now, a lot of the co-developers are actually being paid to work on the project. That wasn't really the case before. And so there's 3 different kinds of funding models, basically, that we're using right now. So I'm working part of my time on Sci-Kit Learn, though it's mostly governance these days and not so much coding. And I have 2 people, Nicolas Hugues and Thomas Fan, who work on Sci-Kit Learn full-time, mostly coding, and also like doing maintenance and code reviews and all the other things that you do as a contributor. And me, we are funded by basically government grants and also other philanthropic organizations. So that's like the academic model of writing a grant and then someone gives you money. So the Sloan Foundation was very generous and gave me quite a bit of money to get me started. We now have money from the NSF, from DARPA, and we just very recently got money from Chan Zuckerberg. Chan Zuckerberg in the summer started this really great program on like core open source software with a focus on, I think, biomedical research.
Mm-hmm.
These are the sources where I draw my funding from. In Paris, they used to have similar but slightly different model where basically they do neuroscience research. And so they had part of the time that they contribute to Sci-Kit Learn as like sub-items on their neuroscience research grants. That's a very common way to fund open source. The new model is with this foundation, so the Sci-Kit Learn Foundation at INRIA. This is paid for by companies who can have sponsorships. So we have different levels of like gold, silver, bronze. These are company sponsorships where a company basically buys into this and gets in return a seat at the table to decide priorities. So there's the Sci-Kit Learn Consortium, which is the collection of the companies giving money. They can basically meet with the foundation and give their priorities. It's not a direct influence, but it's more of a like they can make recommendations or ask for things and give feedback on our work. There is a third model where someone is directly employed by a company. So we have Adrian, who is directly employed by Anaconda and works on Sci-Kit Learn. So this is a different model again for funding open source in that a company directly pays someone. That's actually somewhat rare, but Anaconda is one of the companies that does this quite regularly for a bunch of projects like Bokeh and Dask.
What does the company get out of that?
So they're a big player, or maybe the biggest player in the scientific Python ecosystem, right? And so they build platform services and they do consulting around the SciPy ecosystem. And so strengthening the SciPy ecosystem means their product will have more demand. And on the other hand, having people directly embedded in the projects also makes them like more knowledgeable about the project. So if someone needs help with Sci-Kit Learn, if you have a Sci-Kit Learn core developer on staff, that's clearly very helpful for them. And finally, they also have like some influence, or at least they have a pulse on what is happening in the projects.
Okay, so when you talk about the sponsorship level for enterprises, do you then see a lot of folks coming in because they're using it in production and they need something fixed right away? You know, it's a hot bug fix, or I need this feature request right away. Does that happen a lot, or is it more about, okay, we've taken your input, please wait, we'll decide what's right?
So the model right now is really much more long-term engagement, in particular because the foundation does not actually have a way to put something into Sci-Kit Learn. So it's still the community that decides in the end what goes into Sci-Kit Learn, what doesn't. And the release cycle usually is about half a year. So even if you do a hot fix, most companies want to use release versions. And so they would have to wait half a year for the hot fix. We sometimes do bug fix releases, but that's only for very severe bugs or if like there's a couple of bugs. But I don't think we ever really had something happening where someone came to us with, here's this bug, fix it. There's like some cases, but it's never been a company. There's been like individual people which were like, hey, can you fix this bug quickly? To which our response usually is, when we get to it, you can fix the bug and we'll review it.
Yeah. So not a hot fix, but maybe like a tepid fix, lukewarm.
More broadly, how would you articulate the core value of open source software, right? So I could just start a company that says, I'm going to make software that builds machine learning algorithms. In fact, companies do this. So why are you in it, and why should more broadly people care and feel passionately about supporting open source software?
My personal motivation is really that I feel creating the software has a really, really big impact. in that it helps a lot of people deploy better models, both in science and in industry. I could potentially have a similar impact with commercial software, but in the outcome, there's two things that are different. One is that this is much more an equalizer in that everybody has access to the software. If you look at things like MATLAB and Mathematica, which are still used in some places, if people go to a university in maybe a country that doesn't have as much funds as the US have, they might not have access to these tools. Or if you have someone sitting at home trying to do their analysis on their own or trying to do some citizen science or building their company, they might not have access to these tools. On the other hand, I think people in general are now a bit more wary about including commercial software anywhere. And I feel like generally commercial software products are probably sort of dying / dead. Most software that you can buy is services, right? I think even Windows is like now under the Azure division in Microsoft. So Windows is now a tool to sell cloud computing, right? Windows is not a product in its own anymore.
Right.
It's a tool to sell a service. And so I think there's not actually that much space for a commercial development of software. And that's just so that was more on the like impact part. There's obviously also a lot of things on how does it actually work. And so having an open source project gives you a lot of freedom in what you actually want to work on because no one is boss. And what people found is that this actually leads to higher quality software. In some cases, it means software develops very quickly. In other cases, depending on or maybe let's say the pace of the software changes naturally with the maturity of the software and not with sort of the deadlines. So Sci-Kit Learn now moves quite slowly because it is quite mature and it's quite widely used. And so we're not going to make any abrupt changes. And we know we shouldn't make any abrupt changes. If you look at like TensorFlow, which is maybe similarly widely used now, they actually made an executive decision to change everything and make everything incompatible. I'm not saying that was a bad move, but it's definitely like a very different move, and it's more of a top-down move than a bottom-up move. And so having this more developer-driven and community-driven development, I think, is something that I find really engaging in open source.
I think it's great. It's actually democratizing machine learning, and the people who are developing it are the ones who are also using it. I think that has a real value there. So how do you guys then ensure sort of the integrity of the product, right? And not to say that you as developers or even open source contributors are not good, but when you think about the differences in coding styles and practices and even methodology for like a given machine learning algorithm, how do you guys make a decision on what is considered good practice and correct for this huge project?
So in terms of procedure, everything requires code review by 2 core developers. That is sort of our minimum quality on standard. In terms of what do we include, we have pretty strict standards on like how widely used an algorithm is and how mature the algorithm is. In terms of actually ensuring the correctness of an implementation in machine learning is quite hard. And so I don't think we have like a solution to that. There is this saying from open source that many eyes make every bug shallow. This is what often leads open source projects to have actually better code quality because so many people can look at the code. But it doesn't mean that there's no bugs. And if you look at the issue tracker and you look at the bug flag, you'll see there's many of them. But there's probably still less than in any commercial product. Or at least they're known and you can see that they are there.
Do you see a tension between the two kinds of users, the corporate enterprise people who are sponsoring sklearn and the individual contributors or maybe, researchers, university folks? Are you building sklearn to try and please everyone? Are you just building it for yourself? How do you manage all of these competing sort of people in the room?
I think it's quite interesting because there's been a transition between these. So I think all good open source projects start as being built for yourself. Like if you don't have a need that you're filling with the software, you're probably not going to write good software. But now myself, I mostly don't use it that much unless I use it for teaching. And I'm mostly now developing. And I think the same is true for many people in the project, that now we're more developing it also for other people. And initially it was clearly with a scientific community focus, but now we broadened more to industry use as well. But I think to answer more your question, like now we try to please everybody in that we definitely want to make sure that the original community of scientific users are still served while also better serving industry. Though there's like a couple of things basically in how we scope where we want to go that limit both of these. So there's a very interesting point that I think someone from the Matplotlib project brought up recently is that a project can either be an application or a library, and an application tries to provide things that are easy to directly use, whereas a library tries to give you a collection of functionality. And Sci-Kit Learn decided to be more of a library, which makes it a little bit tricky to use in a couple of cases. If you compare it to R, it's much more of an application that it tries to directly interface with the users. And so there's a thing that's slightly missing maybe in that something that builds on Sci-Kit Learn, but that is more directly for the data scientist to use and more as an application that does easy things in a nice way simply. Whereas Sci-Kit Learn tries to be really strict and it's really clear what is happening and you have to be really explicit about every single step, which is good for a production environment, but not so good for like interactively hacking around.
So sticking on the thread of RStudio, I would love to hear your thoughts more broadly on, you mentioned this cool distinction between a library versus an application. So you developing a library, open source toolkit, what is your thought and your ideal way for for-profit companies to come in and basically provide, I'll call it managed open source services on top of what you're doing, which is fully, again, open source?
So I'm totally happy for anyone to do that, right? That is the point of open source. It would be great if they would give something back to us, but they're not. They don't have to. That is the point of open source, is they can take it and do their own thing. And if they can build a great product, then everybody's richer. On the other hand, I'm not sure I believe in that happening right now, which is maybe a little bit tricky given that we're here at Data Haiku. And what I heard from many companies is that they find it hard to find a real value add and like figure out where exactly they can place their product. Because there's a bunch of companies that over time try to like serve Sci-Kit Learn in the cloud or something. And like most of the bigger cloud providers have some form of integration. Mm-hmm. You can ship a Sci-Kit Learn model on like Amazon SageMaker. But so it is at a point where it's sort of slightly too easy for it to make a good product to bridge the gap, but it's also still too hard for the user. So it would be nice for it to be easier, but I don't think a lot of people are willing to log into a platform to help them ease that because it's not actually that hard.
To this point about making ML more accessible, whether it be understanding the coefficients on the model or something more broad, can you maybe describe your work with Dabble a little bit?
Dabble is a relatively new toy project of mine. It stands for Data Analysis Baseline Library. And as the name suggests, it helps you to dabble with data science problems. I've been interested in automatic machine learning for quite a while. And so automatic machine learning is about finding the right model for a problem and tuning that model, tuning hyperparameters, and so on. However, if you look at a data science workflow, this is only a very small part of the data science problem. What's interesting about it is that it's very easy to automate, in a sense, compared to the other problems. With Dabble, I'm trying to look at what are the different pieces that work that you need to do to get a minimum data science workflow going for a supervised learning task. And so it starts with like data cleaning, data visualization, building initial models, searching more complex models, and then trying to evaluate and analyze your model. And these are sort of the basic steps. And I want to make sure that each of the steps is as easy as possible. In many applications, just getting an initial solution is something that's very valuable, and you don't really necessarily need to tweak out the last percent. If you look at things like Kaggle competitions, it's really about like you have a fixed data set and you want to get the best possible model. That's not really how data science works in the real world, where usually you get new data and you can change what data you collect. And so I want to make sure that each step is as lightweight as possible so you can easily iterate between the steps. And so there's a bunch of tools in Dabble for doing pre-processing, for doing data visualization, for doing some automatic machine learning that is quite simple, but probably good enough. Then some automated ways to do model debugging plots and so on.
So it sounds like it's, like you said, the baseline. And the idea is not to have it be push the magic button and get some output, but rather a a starting point for someone looking to build out the flow. That's awesome. Is that also open source? Can people contribute to it?
Oh yeah, of course. It's completely open source, and right now it's like mostly developed by me and a little bit from some people on my team. It definitely needs a lot more development, but I think it's already quite useful. Like I added a couple of new plots. If you get a new data set, like the first thing you should really do is to look at it. And plotting for supervised learning is not that great in Python. And so it really gives you some, like all of the plots that you want to see very immediately. And it figures out which are the interesting plots and all these things. So you can very quickly look at the data set to maybe see data quality issues and so on.
Well, thank you for joining us today for this conversation. It's been great. Before we go, one question for you. If there was anything in the world, not software related, that you could have as open source that isn't currently open source, what would that be?
I think I would probably pick the US Constitution.
Okay.
Mic drop.
Oh, yeah. Mic drop.
It's really the operating system on which the country runs, but it hasn't been updated in a really, really long time. Maybe it could use some patches.
I do think you'll have trouble with consensus on that one, though.
Probably, yes.
And by the way, Dataiku is a silver sponsor of the Sci-Kit Learn consortium discussed in today's episode. We'll be hosting the Sci-Kit Learn sprint in our Paris office in January. For more information on the sponsorship, check out the show notes below.
So for today's Banana Fact, keeping in the spirit of the month of December, I have some information about holiday lights, right? So we all put up these lights on our house, on our trees, on our whatever during the holiday season. And actually, those lights, if you're not keeping them year to year, get recycled. And so every year, over 20 million pounds of discarded lights go to China, where it's considered the Christmas light recycling capital of the world. And so these Christmas lights are basically pulverized. They get separated into brass, copper, plastic, and then get turned into a bunch of new stuff, like slippers and different kinds of gadgets.
That's surprising and disheartening. People, keep your Christmas lights. Recycle them. Use them year to year. Don't throw them away.
But if they're broken, Will.
Oh, right. That's all we've got for today in the world of Banana Data. We'll be back with another podcast in 2 weeks. But in the meantime, subscribe to the Banana Data newsletter to read these articles and more like them. We've got links for all the articles we discussed today in the show notes. All right, well, it's been a pleasure, Tiffany.
It's been great, Will. See you next time.